2024. I have already, imagine we left here yesterday, I have already scanned the handouts which I told you about. I have already scanned the practicals in the manual, and I added them under experiments. So under experiments, I added all the experiments that we shall do, beginning with D4. So I will put D4, introduction to flip-flops, then aim, operations of flip-flops, then I put E17, I put E19, I put E22, then I put E, is it E or R? R. Then I put R, and this is introduction to robotics. Aim to use a Lego robot to know how to use, or how sensors are applied, sensors and transducers. Because with this we have a light sensor for the line follower, we have a touch sensor, and the ultrasonic sensor for the explorer, and of course those three will be able to give us. So they will make 5, and then the groups where there is R1, R2. So where there is R2, there will be E17. But I will regroup it. I found out that in the evening I wanted to do it, but the Excel was on my PC at home. When I reached home, I'm always tired like a vegetable. I just want to sleep. So I will work on it. A vegetable, when they cook it, it cannot just there eat it. So hopefully over the weekend, I will complete everything so that by Monday you have everything stated out. And then Wednesday we make this lab easy. What else did I do? And then under this, so on the description of this, especially on under the R, I put bullets. So NXT1, NXT 1.0 for Explorer. All the instructions I put them there. Then also I made R the link. When you see them greenish, it means that it is a link. So on the R, I put the introduction to the robotics. I made it hyperlink to go to the general page for robotics. The different versions. If you want to go straight to them, the instructions are there and the like. But then under bullets, I put instructions for the building instructions for NXT 1.0 Explorer, NXT 1.0 line follower. Then NXT 2.0 for Explorer, instructions NXT 2.0 for line follower. So you have no excuse. And for these other ones, when you see D4 flip-flops, then it is highlighted. When you click on it, a PDF of the scanned copy, which of the copy I scanned, shows up. So you don't need any manual anymore, you don't need to take screenshots anymore. You can access the instructions anywhere, and my strategy now, at least for the older manuals, I want to scan all of them and make them available online for anyone to look through. Then for the new manuals, I have the PDF soft copies, so those ones I just pick out. Like for electromagnetism, I picked out the experiments that you would have done. So you can still go there and check through the background of the pre-prac and whatever, and know what you could have done as practical, and then Google and then see what you could have done in the lab that you couldn't do. If you can go to another university and do it, well and good. If you can go to a factory and do it, well and good. Or you can fly, go to Nairobi or to Harvard and do the experiment. Some of you are very rich, so I cannot underestimate you. I once taught in a school where when kids go for holiday, they are in Boston, they are in New York. Then when I'm just there telling them stories of looking after boats, they are laughing at. They are just looking at me like I'm some alien. So I had a challenge until when I think I told you, until when I got a trick. These are sons of ministers, MPs, generals. So I was confused. How do I encourage them to study? Me. For you, when I tell you I looked after boys and now I'm here, you may say, I looked after boys in here. Me, I was in a good school, I want to be better than him. But for them, they have already finished. They are in their future. So I told them, what if both S5s I was teaching and S2s, I told them, what if you worked hard and made an agreement with your dad that when you get medicine or government, they deposit the money for fees on your account. How much would you be having after 5 years of medicine? You'll be able to buy a vehicle and make your own clinic. From that day, they started concentrating. So I would teach like a kid without any hassle. Otherwise, the girls used to have short dresses, and then they would sit on these plywood chairs and even cross the legs. But I also used to put on Mandela shirt. You know Mandela shirt? These shirts which you can't tuck in, so I would be free. My Mandela shirt. So it was a struggle. I think I was just from here. And, but I managed to get a trick of how to survive in a strange environment. So now that Fred has come, I can start. When Fred is there, everything is okay. So, why are you arguing now? It is me who determines who is important. For him, he came, he didn't even know the time we are supposed to begin. He's like, sir, are we having a lecture or not? So you're not so sure that you are confused. So for you, I have pushed you aside. So last time we were able to conclude on the 7th segment. There are a bunch of things that we didn't write, but when I have organized and scanned the notes completely and I post, you'll be able to go through on your own, because now I need to be quick. Did you cover thermocupo in your thermodynamics? I want to jump that part of thermocupo also, but which is so important. So I want to go straight to, I talked about resistance thermometers, and we have strain gauge. I'm just trying to make sure that this is a fair kind of thing. I don't know. I show you that I'm working hard, but you don't want to show me that you can work hard. I don't know why. Senabuli. When you are walking, you come like this. Then you open the door like you are a robot. Then you pass around like this. Then you enter.
It's just that the better has been tiresome there on my side.
Then?
Just for today, just because it has been tiresome, such a tiresome day on my side.
You are doing part-time or?
No, not part-time. For recess only, we had fixed schedule. Fully. Just for today.
But others also are like that. Are you stressed or what? you share with me. A problem shared is a problem half solved. You never know you can give it. All I want to tell you studying is suffering. That's what you should know. You did not come here to enjoy, you came to suffer. Get your degree, then you can decide to enjoy. But I can assure you, even in working, we don't enjoy. But we are only confident, we are only comforted by the salary. At the end of the month when you see the money. And then you can pay fees and put fuel, repair the long-time mechanical problem that the car has been suffering with. Then you say, okay, I have been doing something for a reason. The only thing that will make you happy is when you excel, like when you pass. First of all, when you pass and you are able to graduate, and also when you get a good class. Otherwise, you will continue suffering. So, no, I think that like they made an advert and they said people have to have a 4 point. So I think it is stupid. If it is an upper, it is an upper. Whether it is 3.6 or 4.49, it's upper. So if they want to change the rules, let them say Bakerere upper is 4.0. I'm waiting for, the deadline was done, I'm waiting for, you can't tell me that my student here should compete at 4.0 with somebody from Chambo or KIU or anywhere else. Are there choose people who apply to come to physics? I don't have any student who have connections. This student, what do you eat? I feel I should cover these parts because if I don't exhaust temperature sensors, I don't see any sensor, anything else that any physical quantity that can be used for sensing other than temperature, pressure, speed, or velocity for that matter, and then I start rushing for other things. If we can get these basics, then it becomes easier for you to see how to manipulate a couple of things. So let me not jump. Did we cover LEDs as compared to the LCDs? Yes. No. So we ended at the advantages or disadvantages? Screen display. And we said we can produce a steady picture, and that's where we stopped. That if the screen is refreshed, TWINAMASIKO produce a steady picture so that you see people dancing, if it is a song or people or someone reading news, whatever it is. Did I number screen displays or I just said screen displays? Screen displays. Okay, so let's now that we are almost set, you know, we know each other. We don't expect anybody else to pop in. Shida, where were you yesterday? It's classified. So since we are now in line, those of you, since you have come late, and today I'm going up to 7:30, and yes, that's what we agreed. And because so it is now 4:50, so we shall go 7:50. Because that's when I'm going to start. Simply what? You stay very far.
Not really, but when I called, that wasn't the agreement.
What was the agreement?
We had agreed that we start at 4:30 and we end like 6:30.
Well, and that is after we had changed from where to where?
After we had changed from this day to the next day, that we shall be using some of the next day for theory.
What time of Wednesday?
The practical time.
And how will we be doing practicals?
For the practical thing, we have agreed that we shall be doing a week, then we just a week, and do the other week. Shall be just
so the jump we weak. The jump we weak, we shall be using all the 2 to 6 for a lecture.
Yeah.
Clarification is here.
Eh? Clarification is there.
Yes.
Hey, that one.
We say that on Wednesday or
You
some.
recorded it.
Yes.
That I said what?
We say some Wednesdays that have no practicals, we shall be studying from 2 to 4. Then today it is from 4:30 to 6:30.
You guys should have done law. Okay, you have nailed me, so what can I do? So that means we start with the what? The one of first or second?
You can start with
Is the one?
second.
It is of second.
The
I
one
think.
of the second will have a practical.
We have a practical.
Yes. So the next Wednesday.
Next Wednesday. So let's look at 7 segment displays. Going to, it's okay. But why were we ending at 4 on those Wednesdays? You wrote it also. You didn't write it. So yesterday, those who were, before yesterday, if you go to the course and look for, you don't need to look for this link on the course. I'm now trying to make Mwere look nicer, at least for my courses. Instead of looking for, in weeks, to look for the course study materials 2024, I put it on the top. So there is click here. First here is for the registration form. Anyone here who was not registered on the form? You still have issues. Okay, so if Shira, what issues are those? Fred can help. What issues are those? He's good at computer. Or phones, at least online, he can help. You forgot the password, you...
Yes, I forgot the password, but now
Hmm?
I had forgotten the password, but now I got it.
Got a new one.
Yes.
Then my... You just don't want. So, under experiments, I have now made experiments a hyperlink. When you click on experiments, all the experiments that we are going to do come up. And all of them are hyperlinks. So the experiment of D4, I scanned it like I promised yesterday, and now a PDF is there of the procedures. The one of E17 is there. And the one of 17, we shall have a new skill. We shall be using a board, a logarithmic log graph, where we shall be drawing the board diagram. So you have to learn how to draw a board diagram on a logarithmic graph. E19, I put the, so E19 and E22 are handouts. So I scanned them and they are here. You do not need to take any photos. The PDFs are here. Then the robot, introduction to robotics is hyperlinked. It takes you to the general page of Lego robots. So you find different versions. Our version, the version of one of the robots, the NXT 1.0 is no longer available in the market. The NXT 2.0 is available in limited amount if you wanted to buy. Then there are new other ones and old ones which are now distinct. But the instructions on how to make a Explorer for NXT1 and NXT2 also, the links are there. You click on it, it takes you to the page where these construction instructions are. How many pieces do you get for this, how many pieces you get for this, then you construct the neck, construct the caster board, then attach the sensors, then UVC. So all of them are here, and then at the bottom of the page, there is a return to the whole, to the page of course material. So I'm making sure, even on electromagnetism, when you are notes, I also put at the bottom a link that takes you back to the page of the course study materials. So I'm making this page here to be the whole course. Then the other one just for purposes of flowing with the weeks. But I want to make sure the whole course is on this course study materials for 2024 with the videos. Every time I leave here, I go upload the video so that you don't have an excuse. If you are reading and you find that you wrote something and you don't understand, you go forward the video to the point where I was talking about that, hear how I talked about it, or whether like in electromagnetism, how I was trying to write wrong things when they are writing the notes, then you confirm that I made it wrong on whatever. By the way of how the viewership is on my videos, it shows that you don't watch them. There's no video which is above 6 views, and I have 21 people who normally register here. You are trained, that's it. I'm not complaining, I'm just not even just saying let me just go and have uncle of what it is. So you say we are 10. And yesterday you were not there, and you are saying we are 10. So I just wanted to make sure that I let you know that when I left here, I made sure I scanned in things. Just in the span of yesterday I was here, by today now I have already scanned in things, made the page, made sure you can access the links to the different places. For you, you don't want to do anything. But God is there. He knows the truth. They are generally employed. Or used. Employed is not like the paid salary. In indicators, of small numbers. Small numbers, and they consist of a number of leads, arranged in 7 segments. You can't have a billion displayed by 7 segments. So the small, when we say small numbers, you know, like a petrol station, you got a couple of whatever. If you look at the functional generator, you are able to have a couple of Ha's displayed on it. So that's what it means by the small numbers. So they contain a decimal point. They contain a decimal point, which is normally represented as a dp. So I don't know, there are a couple of segments that I have drawn here. I don't know whether you'll be able to draw them very fast so that we don't spend so much time. So this is the whole segment being a 7 segment, which is like an 8, or which is an 8%. For me, drawing is not my problem. I course, the decimal point is here, VP. And then we have, e.g. if you want to show a 7, if you want to show a 7, then you light up the, you show A, B, C. You show A, B, C. If you want to show a 5, this is a 7. If you want to show a 5, we shall show a this is a F. Is it visible? So this is A, B, C, D, E, F, then B. This is a 5. You can draw on your own as an exercise. You draw that of the 9, that of the 9 has 2, then a 0, and that would be enough for you to do practice. A 9 has 2. There are displays which show a 9, which is A, B, C, D, E, F, G. A 9 which is like this, a 9 which is like this, and then there is a 9 which is simply this. You find some watches giving you a 9 without this other part, without this. So a 9, there is a 9 which is like this, and then there is a 9 where this is the one, this is not there. And they are all 9s. So a divider, this is it is a decoder, not a divider. A decoder is required to connect the digital signal in or to be displayed this chalk quality is very poor. I don't know why. To be displayed in the corresponding corresponding 7 segments here. So when I'm adjusting the functional generator, the decoder will be busy sending that now your turning has reached 100 Hz, 200 Hz, kilohertz, these many kilohertz. And then it displays. So in other words, we will have a clock which is producing the signal, and this clock would be fed into a decoder. Which is a count, which we can say decoder counter, and then we have a binary code output from the decoder, which we will feed in the binary code to 7-segment decoder. Then we finally get to the 7-segment display. We are just trying to get acquainted with the theory behind what we see. Normally we see things, but we don't care what is behind, what is inside what we are seeing. So the clock is anything which can produce counters, whether it is the function generator which you are adjusting, whether it is the value on the digital meter as you adjust the values of the voltage, like when you are trying to adjust the voltage on the experiment 2 of the solar diode, all that your efforts to make sure you adjust the voltage, that would translate into a counter and then be decoded to eventually display on the multimeter. So that's the clock we are talking about, as anything that can produce the counters in digital electronics. When we had the high, low, and a decade means how many years are in a decade? I saw that on the TV when we were interviewing university students, and one said it is 365 years.
10 years.
If you are 10. So this means 10. A decade means 10. So BCD is a binary coded decimal. BCD, which I have been writing, is binary coded decimal. Binary coded decimal. Do you remember your base 2 mathematics? So if we had a 3-7, if we had a 3 and 7, we would have, we could write it as 7 B, which is the same as a 0, 0, 1, a 0, 0, 1, 1, and 0, 1, 1, 1, with binary coded decimal. And so a 3 is how much in base 2? 1, 1. So, but we write it as 0, 0, 0, 1, 1. And then 7 in base 2. Sega is laughing. Shidad, what is 7 in base 2? You divide by So it's 1, 1, 1. So we write it properly as 0, 1, 1, 1. And then when we, in the format, if we want to put in the decimal, is equivalent to this in the binary coded decimal. This is not my intention, but just to make sure that you get acquainted with the nomenclature. We already listed the disadvantages of displays, and there is a pattern jumping for the how they light up when you compare with the inputs. And the next one is about the implementation using gates, then the connection using the common anode LEDs and the common cathode LEDs for the display, 16 segment or dot matrix displays, the 16 segment, 6 by 12, the columns, and all that you will have to read on your own. You are big people. I'm trying to make sure that we chop so that we are versed with the course by the end of this place. The problem is the 2 weeks that I may not be around. Those 2 weeks are only 2 lectures, but they mean a lot. Because these notes are available on Mwede, like I'll make them available on Mwede, I shouldn't really suffer writing them. So we go to the Tlamokupo. The Tlamokupo, each one can look for it in their own. So when Voltaire was busy doing dissection of the frog, he had already killed the frog. So when he was dissecting the frog and he had already killed it, and now he was just trying to understand the parts of the frog, he placed a tweezer somewhere and the frog kicked. And then he was perturbed. He said, why is this frog kicking when I've already killed it? Because he had already sliced the neck, he had already split it, all muscles were out, it had already been just shaking like this because it was dying, and it had stabilized, meaning that it was comfortable, it was dead. But when the tweezer, you know tweezer? The tweezer is a piece of metal which electricians use it, doctors use it. It is like this. So it's like an example of levers where you apply the effort here with an imaginary fulcrum here, and then the load, whatever you want to grab, is always here. This is where the load is always placed. So it is stiff. When you make it hold something and you have taken it, if I make it hold a piece of chalk and I reach where I want to put it to release it, it is able to retract back. And then when you want, you grab it and take it back. So someone who was always suffering with chapel, until I got a piece of wire and bent it nicely like this. And the other part like this also, so that you just grab charcoal instead of looking for gloves or finding that your hands are all dark like you were burnt. So I used physics for a tweezer. Bending a wire, these strong wires which do not just collapse. So you just grab a piece of charcoal, put in the suki. I grew maize, so when my maize, the other one I have planted, it should be ready when we are finishing the course. So I will bring here CBD and charcoal during our cocktail so that we roast some. I will see in December they will be ready. They don't have planted now.
Yes, yes.
Now, you planted in September.
I planted, let me see, I planted, I was speaking 26 per, so I remember I did like 4 fists or 3, those are 60. You are just 30, so if they are ready, I'll make sure each one has a piece. Bring here, we make it, each one roasts their own fresh maize. Then we eat the snacks and we have a good evening. So pray hard that they all grow and put, if they don't grow and some of you will just look at us, others who are eating. So back to the voltaire, that's how we got the volts for voltage. When that happened, he tried now to make some experiments until when he discovered that when you have metals of different types, then when you make them meet, they develop and there is a solution. Some electricity is formed. Similarly, when you get two metals of different necks and you make a junction, and then you make these two to be at different temperature, then you can develop a voltage across them. That voltage would depend on the temperature that is being experienced at the junction. And then you can interpret that temperature, that voltage as the temperature that is being experienced. So I don't know whether when you are walking or doing something, you tend to look at, some of you, I don't know, even most of you, you just wake up, you walk here. I meet people on phone like this. He's walking, he's almost falling down, but you see he's very good. I think on social media there are those who are hitting poles. Someone is walking, it's a pole, then others fall in these manholes. They just fall there and it's like they are drunk. When you are drunk and you fall, it is normal. You just wake up, you don't complain. You just stand up. I was drunk, I got drunk when I was young. I think I used to escape home and go just to look at the electronics if it is a wedding. Me, I am with DJs. I was like a small boy, looking very nice. So they would like me and say, it's okay, you sit here. They get drinks, what. But for me, I'm just mesmerized by those lights, which keep doing like this. So one time they came to pick me. So the place had a terrace, and I think they had given me our local brewer. So me, I saw a terrace that I could just step like this and move. But my step was short, so I just slipped with my bag down and running away from those who had picked me up. But it wasn't that I'm a stubborn boy. Me, I just wanted to see technology. And now when I'm old, I am doing it with annoyance. I buy them when I want. If I see a camera and I like it, I just buy. If I see a drone on the internet and I can order it, they bring. I don't have. The principle behind the thermocouple is that if two different metals, A and B, are joined together, there is a difference. In potential. There's a difference in electric potential across the junction. And this potential difference is called the junction. It's called the junction potential. So we have a metal, this is the junction, another metal, and then we have A, B. And so we develop a potential here. We have ET across AB. This is when you have a potential gradient is the same as electric field energy. Where is Chibida and Shakira? For Navas, I don't know. Then there is Chivuka. The weather. Each alphanumerical character, is denoted by a number. Is denoted by a number of dotting matrix. Is this, I'm trying to understand why I'm writing this stuff before we talk about the actual thermocoupler. This should be about the presentation of the. So I will mention this when we are. This actually should be part of the previous notes of the display, the 6 by 12 display. So ignore this. Sorry about that. Okay, so sorry about that. We go to the temperature transducers as this is just about a thermocoupler, but this thermocoupler is an example of temperature transducers. We saw the radiation transducers. And what do we need for, what are the parameters on the temperature transducers? Do you know parameter? The parameters of your school time is school fees, pocket money. When you're a student, the parameters you deal with is pocket money, school fees, requirements. Yes, you don't get requirements without shopping. etc. So, what are there are more other sentences, but this was supposed to be for the part I said you read on your own segments. The following parameters under the temperature transducers, the following parameters determine the method, determine, and there people who pronounce it like that, determine the method used,
Same one.
the method used So when you are measuring temperature, most times you may need to be aware of the temperature range. So if you are going to measure the temperature of a malaria patient, the range should be between 0 to around 40, because the normal body temperature is 25. Room temperature is 25, then body temperature is about 35 or 37? 37. So you may need a range of like 0 to 50. So you cannot come with a thermometer of 1,000 to 5,000 and then you place it and you are like, I want to measure this person. So the temperature range is one of the parameters that you may need to be aware of. And then also you need to know the accuracy. It can measure up to how much accurate is it in order to use it. Then does it, like when they were shooting us in the face, did you do that? Did they do that to you? Come with a temperature gun and you stand like this and then they say, oh, it is okay, you can enter. So it was always tense. You come and me, I used to put the hand like this. I don't want you to injure my forehead. How do you put a laser on my forehead? It's not okay. Then if you had just put the thermometer in the patient's armpit and then you have read and you want to confirm, how quickly does it give you another value? So the repeatability, consistency. Repeatability, consistency, in other words, consistency. The consistency is that if I put it now, we haven't changed, the kid hasn't improved, then I remove, I first read, then I take it back, then I put, to get the average. Is it able to give me something, repeat something for me? Then conformity to universal curve, conformity to universal curve. We cannot be in isolation just because we already say this is Africa. We should be able to, what we are using, we should be able to, if you went to UK for a study visit, you should be able to do the same experiment you did here and get most likely the same results. A Toyota car, like my shopping basket, if you go to US and it is the same type, it is the same type. When you open the bonnet and you are trying to check stuff, whether water or oil, the same parts. That is the conformity. And also, depending on where you want to use it, size will be a parameter to think about. And then there is one factor that determines all this. And what is that factor that determines everything that you want to have? How much can you buy it? Price. The price to realize that thermometer. The more sophisticated, the more nice something is going to be, most likely the more expensive it becomes. So the constant potential depends on the metals A and B. We had already drawn the diagram as a junction here. Then AB, then we have the E So the constant electric potential, the constant electric potential ETAB depends on the metals. Otherwise we would have called this electric density if we don't find it. Depends on the metals A and B. And the temperature. T degrees Celsius of the junction. It is given by a power series. It is given by the power series of the form ETAB which is equal to A1T plus A2T squared plus A2T squared plus A3T cubed plus etc. These coefficients AI, the coefficients AI depend on the metals, the two metals A and B. Depend on the metals A and B. E.g. for A equal to E.g. for if we have A being iron and B being Constantine, is it like this, Constantine, which is type J? Type J thermocouple. Then we would get that A1 is equal to 5.0. A1 will be equal to 5.07, 037 times 10. Then A2 will be equal to 3.043 times 10 to the power negative 2. A3 will be equal to minus 8.567 times 10 to the power negative 5. And A4 will be equal to 1.33 times 335 times 10 to the power negative 7 plus higher terms plus higher terms of up to T to the power 7. And those people know that when they pass it is noisy.
They should pass the
So A7T to the 7, whenever they pass they make noise. Doesn't matter. So what would be A7 equal to? I think we have thermocouples in the other room. Have you done solar? When will you do it? Next semester. Okay, if you choose to, because I think it's also an electric. But in the lab, in the project lab, there is like not an experiment, but there's a setup for heat storage, which uses thermocouples. So we can take the closed circuit for a thermocouple for a closed circuit thermocouple. Consisting of two junctions, of metals, at different temperatures, T1 and T2. So if we have these two metals, and we have our sinusoidal galvanometer, and then we have two junctions here, one at T2 and this one at T1. And this is the same metal, BB, and this one is A. Then we can measure the potential here, ED. So the EMF that will be developed across these two due to these junctions, and being that these two metals are different, the EMF is approximately given by the difference of the contact potentials. The EMF is approximately given by the difference of the current potentials. These things you should have covered them in either properties of matter or heat and thermodynamics. So the difference in potential would be the potential at the junction 1, which is at temperature T1, across, which is between these two metals, minus the potential at the second junction at T2. And this can be written as, remember, ET1, okay, ET was A1T plus A2T squared plus A3T2 plus plus. So this implies that we will be having A1 in T1 minus T2 plus A2 in T1 minus T2 squared plus A3 in T1 minus T2 cubed plus 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 plus. Usually T2 is the temperature of the reference junction. Is the temperature of the reference junction. So if you had the temperature, room temperature, so one junction T2 can be outside on the room temperature, measuring the room temperature, and then T1 goes to the place where you want to measure the temperature. Then the difference between the two would give you the temperature that is now being developed on your system, because you have a reference temperature being T1. Which my poor handwriting is not coming out easily for you, so that I can say the word of the contact. So this will be contact. I said it, but I'm sure you, even if I were you, I wouldn't hear. I would be busy writing. But I normally say them for record of my videos. So this T2 here is the reference temperature. So you have your side being like outside, which will be measuring, giving the room temperature. And then you have this one being enclosed in the system, for example, where you are trying to measure the temperature. So the difference between these two, the T1, which is probably higher or lower, depending on what your system is. If your system is cool, the T1 will be lower than the T2. And if it is, if the temperature will be high, like a heat storage, then you will be having T1 being higher. And then you will end up having the temperature that the T that we were talking about being the same as T1 minus T2. And then you will be able to do whatever else you want at the end of the day. So the T1 is the temperature of the measuring junction. T1, T2 is the junction of the reference. T1 is the temperature of the measuring junction. The temperature. This is not. Is the temperature of the measuring junction. The junction that you are using to measure the temperature that you want. So if your reference, for example, is about 0 degrees Celsius, then we will have that ET10, this is ET10. This is ET1, this is ET1 T2, ET1 T2, AB is equal to this. So now ET10, where there is T2, we put a 0, so it will become A1, T1 plus A2, T2 squared plus A3, T1, 2, plus. Just the theory for you to get a feel of, so that in order to find the accurate estimate of T1, the above non-linear equation must be solved, and you can use a microcomputer, a laptop, any program. Aren't you doing the computation of physics or computer programming in physics? So that in order to find an accurate estimate of T1 from ET1, this should still be AB, because we are are still having these two junctions we have on metals area. Estimate of T1 from ET10 across the two metals AB, the above nonlinear equation, this one here, the above linear equation is solved. You cannot use, whether you use your manual way, I don't care, but you can use a microcomputer. You don't need a quantum computer or a supercomputer. A normal computer you can use MATLAB, put in the values. Once you have measured the T's, then you put in and be able to measure and get the value of the measuring junction, which is the T1. And then you'll be able to measure the temperature. So this method, as you can see, you are not worried that your thermometer is going to get burnt, or if you are going to use a mercury thermometer and you are going to put it in a heat storage, which is going to be at probably over 100 degrees Celsius, then it may get spoiled. But here you are just having a junction with two metals, which iron does not melt easily. You know, we cook with the, do we have they normally say flat iron. Is it because it irons or it is made of iron? Whatever the case, at least you are sure that these metals are not going to be spoiled. You just plug them in your system, and then you have the other junction is outside for the reference temperature, and then the potential gives you the value. So using the 7-segment display, you start reading the values on your display. In other words, what I'm trying to show you is that the moment you know how to make a display, the moment you know how a display is formed, you now have a thermocouple. Then you can make a gadget, an instrument. This is called electronics and you can make an instrument having a thermocouple, having the 7-segment displays, and someone will just get the junction, which is a probe, push the probe into where they want to measure, and then they just start reading the values on the display. So you would have made an instrument. How nice it looks, how complicated or how appealing it looks for it to be bought would depend on your ingenuity. But the principle behind is the principle of a thermocouple. But for you, you just bring and say, if you want to measure temperature of your kiln, is it called a kiln? If you are like these people who, if you do material science, you can end up with a Johnson and go to clays and be able to start telling them, no, the way you are burning them up is, the way you bake them is not good. To bake them nicely, you can do this, and they will never break. So in order to give mechanical and chemical protection, in order to give mechanical and chemical protection, the thermocouple, what do we do to it? If we don't want it to be spoiled by chemicals or be broken, what do we do? It is usually thermal wire or sheath, or a thermal sheath. Some just put in a wire that has good thermal properties, that the heat would, the temperature would be able to be felt within. So, and an alternative to this, is a mineral insulated, thermocouples. So we have a metal. We have a metal case. This is a metal case. The person who supplied this job should go to prison. One does that. The problem is I had and then it is having metal insulation here. And another insulation here. And then this is we have thermocouple wires will pass here. Thermocouple wires, it is all not thermocouple wires. Then this is a metal insulator. Do we have metal insulators? Metals which can be insulated. Then metal casing. Are you sure you don't know of any metal which doesn't allow? Is there any metal which doesn't allow heat to go through? Or which doesn't conduct heat? Have you ever seen some fabric that does not get burnt? I found one in an umbrella or something like that. I burned an umbrella, and then there is this, I don't remember, an umbrella or something. And then you see whitish, they are like threads, whitish, but they don't burn. You put in fire, but they just remain nice. I think that's how they make suits for the firefighters. The mineral insulator, mineral insulator, is both a good heat conductor, and electrical conductor. So you know something about the thermocouple. You can go now read more about it, but basically the main thing is about the principle. Having two metals that form a junction, and across which junction you get an electric which equipotential can be interpreted as the temperature experienced at the junction. And when you use two junctions, you can easily get accuracy by having a reference temperature. Mostly if you are having your thermocouple in a room, so you make sure one side is measuring the room temperature and then the other one measures the temperature of whatever material that you are trying to look at. So then we look at a couple of temperature, sorry, not temperature, but resistance thermometers, and then look at the advantages so that by by next week we start on how these mobile phones work. Why am I able to slide and tap with confidence? How does that work? Which is capacitive transducers. So let's look at resistance thermometers. So I'm very, my vibe is low, but the issue is that you should start thinking that when I put this, or for example, I told you, as we shall see in the capacitive transducers, you can make this door and have an alarm, but concealed in a normal lock. So that when eventually somebody, which I will talk about that, but I'm just trying to talk that, so that if somebody comes and you have locked, your dielectric was locked in between the plates here. So if the person you lock, you engage the other. So that if the dielectric is moved and capacitance changes, then an alarm is triggered. But if you come and you first disengage the alarm, you open, people think there is no problem. Until when they start fidgeting with the lock, and probably they even have a key. And then for them they come and just open as if they are opening a normal door. And then the capacitance gets interrupted. When the capacitance gets interrupted, the voltage changes and then it starts sounding an alarm. Just like a vehicle. If I lock my vehicle with an alarm, with the remote, and you come with a key which actually opens it, you will open it. The moment you have opened it, will start making noise. Because you did not first disengage the alarm system. But when I come, I first unlock it with an alarm, with the remote, and then that means I have removed that obstacle. Then I start the engine and go. Similarly, it has most vehicles have anti-robbery. If you lock it and you have engaged anti-robbery, or if somebody comes and wants, like, jacks the vehicle, that's why it is advisable have the alarm, the remote alone and the keys alone. So if these people who jack cars, they come and say, hands up, you just put hands up, you get out, and then for them, they want now to drive, and then you press the anti-robbery, the engine goes off, and then you run away, since you'll be outside. Like there's a video on social media where the people wanted to how do they call it, when they pick somebody and make them disappear? Kidnap. So friends were moving, so guys came and parked. They ran out of the vehicle, they came to pick his friend. So as they were fidgeting with his friend for him, he ran to, no, they picked the friend and took him to the boot. So as they were fidgeting to put him in the boot, he went to the vehicle and locked himself in, and then they locked the boot, he drove off. with his friend and the vehicle. So they just remained there like this. They tried to run after the vehicle, the man sped off, they went in the bonus. He went with his friend with the vehicle, free transport, and disappeared. But it was because he had a thorough thinking, they call it thinking through. His thought process was too high, that he is in danger, but he saw an opening. But if he had found a third guy there with a gun, he would have been blown into pieces. So it's not automatic that you could find the next kidnappers. I've seen that video. So their friend is inside there. You reach there, it just blows you off. So it's a catch-22. It's a problem that it may not easily solve like that. So we look at the resistant thermometers. So I want you to start thinking different now. And in thinking different, there is what they call design thinking. Design thinking is that you start from down upwards. You start from the user, end user, to the factory. So there were two people. I don't know whether I told you this story last time. You can't shake your head when I haven't finished. To just explain the idea of innovation. A man wanted to open a factory, for example, at Makerere. And then he sent two salesmen, okay, not salesmen, market research assistants, to go and collect information. So they went, and all of them came back with a finding that people in Makerere do not put on shoes. So when they came back with the same finding that they do not put on shoes, researcher A said that they don't put on shoes, we have no chance with the factor of shoes. Researcher B came very excited. He said, nobody got shoes. The moment we introduce shoes to them, we shall manufacture and even fail to get raw materials. Two people got the same research finding, but came with different perspectives. One saw an opening, no shoes, this is the market. The other one saw no opening, they don't put on shoes, we are going to waste our time. So I think one was Isaac, the one who said do you know pessimism? Pessimist? When you see, when a glass, there are people who easily want to say that this is a half full. But then there are those ones who say that this is half empty. For them, they are focusing on what they have done. Half empty. Half empty. Yes, this is Benjamin. I don't know who is this. I don't know who is a bit. These are optimists. An optimist is hoping that things will get better. So he says it is half full. He's looking at it being filled up in the due course. So the reason I'm bringing this up is that you can study the thermocouple. You chop numbers like you did in heat in A level, but you don't care. You just take it that it was for marks, just like how the guy said there are no shoes, there is no factory that this factory will not be profitable. But the other one saw that they have no shoes, this is an opportunity to market them, and they see how shoes are nice, and then we shall sell to even to their grand children. Yes. You have failed to read. The mineral insulator is both a good heat conductor here they say an electric connector, but you should put there and a good electrical connector. The chalk is free, I can repeat as much as I want, as long as it makes us understand. So the first resistant thermometer is a thermistor. Do we take ruler or take singular? What do you prefer? Do you like many things or few? So thermistor, it is a semiconductor. It is a semiconductor. What are semiconductors from electronics? You remember? With the negative temperature. With the negative temperature coefficient. With the negative temperature coefficient. Coefficient of resistance. Temperature coefficient of resistance. Typically of about -4% degrees Celsius. Is he having uniform? Mine. Did he go out with his phone? That is -4% per degree Celsius. What do we use the thermistors for, if you have heard of them? Fred, what do we use thermistors for? The heading is thermometer, and we are talking about a thermistor. So uses of thermistors. Oh, I just write one. Accurate temperature measurement. Accurate temperature measurement. Two, as temperature comparison, as temperature comparison, elements in circuits. What is a comparator? Those are uses. What do you think would be its advantage to the thermotypical,
It's accurate. It's accurate.
They have large coefficient of large coefficient of resistance. Large coefficient of resistance. Coefficient of resistance. What does this help? Because of their being semiconductors, they are not so expensive. They are inexpensive. You can imagine LEDs are cheap, and they have made making, for example, lamps cheaper. They tend to be stable. They are stable. can use them to measure things within a range. Remember, range was one of the parameters we need to take care of. So in a range of -50°C to about 1300 degrees Celsius. Any disadvantages you know? Zili. Any disadvantage you can tell us about it? Huh? So, I told you why I got why I got inspired to become a lecturer. We had a lecturer who gave us a story of the lecturer who gave a question. No, I think that one was told to me by a colleague somewhere. She gave them a question, and it was an example in a textbook. And they xeroxed that exam, and she cancelled everything. And they went to her. They said, we copied this number from an example in a textbook, so like this, and you can't cancel it. She said, who told you I wanted this working? She said, this is not the working I wanted. I wanted you to use another working, and she had another method to use it, and she cancelled their number. So in that case, that two rules. Rule number one, lecturer is never wrong. And then rule number two, in case he or she is wrong, refer to one about it. But that was before I went abroad, and I saw how Bazungu we had one who was teaching us solid state physics, and he would kneel down like this to write on the bottom of the board on the floor. Well, there is no dust there. It's not like your stupid floors. It is clean, they clean it all the time. There is no dust in their place. The chalk is dustless. They use the trick I used last time to clean this board. So he would kneel down, write on the bottom, and then ask you, do you want, even when he finishes lecturing, he says, if you want to understand this, and not just because for us international students, even their children. If you want to understand this, come ask. No, for us, by then I would chop it, I would just chop. If you try to ask, I say, please go and read it. So this principle was working in my head so much. If I am wrong, refer to one above. So if you don't want to know about this one, now becomes exercise. So I still have that kajin, bit, that small bit that if you don't know if you can't give me any disadvantage, so exercise.
I have a
disadvantages of thermistors. Give some. So I don't know how many. You give 10 or whichever you get. So some, but when I say they are inexpensive.
They are non-linear.
Pardon?
They are non-linear.
Okay, you Googled that. So B, is it B, not B because of these? Maybe you could have had 1, 2, 3, 4, or 1, 2, 3, 4. The thermistor we had said A. So B, platinum resistance thermometer. Platinum resistance thermometer. Yes, please.
What is the thermometric property of thermistors?
There,
Thermometric property.
there are some characters, and we are looking at their resistance as the one which will be a measure of their as a property. So, for example, if you talk of a melody, this is a light dependent resistance. So if it is a heat dependent, the one which was, of course we know when you heat up something, when you heat up a conductor, it expands. And if it expands, we know that R is proportional to L over. It expands, becomes longer, that's okay. And then, of course, here also it changes so when you hit something, it does not become big in the cross-sectional area. As it elongates, the cross-sectional area becomes small. So this one will become large or small? Small. Will become small. This one becomes large, so this one will be large. So then you use the issue is, like I said, with these two marketeers, what we see, okay, I wanted to use a very example, but I will have problems. How many of you, when you see a pineapple and then your teeth, even salivation, you start salivating? Any one of you? You get that tingling teeth just looking, and you are already salivating to chew this pineapple. So you just got a message from the eyes, your brain processes, but the response is interesting. Like the output, the reading that you would have gotten on is already salivating. So assuming you have like a saliva measure, something which measures the much saliva you are getting, and then it puts it on a display as a measure of how that pineapple was looking nice, then you will be able to get a value which you can give the units which you want. So that's how they work. They depend on the resistance. The response will be measured in terms of how. So if this resistance was in a circuit, then that circuit, if it is blocking the voltage will be changed. And then it gives us the value of that voltage. But radars the temperature. The platinum resistant thermometer is a coil of very pure platinum. This is a coil of very pure platinum. Platinum wire with a positive temperature coefficient. With a positive temperature coefficient. Of resistance. Of about 0.4% per degree Celsius. So this coil is used to make this thermometer. Not much that I can talk about it. Advantages. Seeing any extremely stable with time. Two, conforms very closely. Conforms very closely to within conforms very closely. To conform means to fit within to a standard curve. This chalk, but I'm sure that everything is visible. I wonder why I have not chosen to have the camera like this. Even in electronics, everything came out well. Words were clear, I could walk here and there. I don't know why I was always putting the camera on the side in previous lectures. And I now don't regret the chemistry people bothering me because now I can use home with the same board rather than their cupboard, which was very scratchy. The range, you still can see here, or I put here, 3. It has a range of about -200 degrees Celsius to about 1000 degrees Celsius. And this is a pretty wide range. This is wide range. Disadvantages? Someone who has not talked. Disadvantages. Kauma. Any disadvantage you know about? Very good. Platinum is not a cheap material. So, most terribly cheap. I mean, not terribly cheap. Not terribly cheap. This language here is not good. Very expensive. They are expensive. But this is how physics people make life hard. Not terribly cheap. So you can add some other exercise, add more disadvantages. So lastly, there are IC temperature sensors. And these exist. Integrated circuit temperature sensors, they exist. E.g., if you Google, you have an LM325. I will check the LM235. No, 325, not 325. Whichever figure it is, once you say IC temperature sensors, a bunch of different chips will come up that can be used for that. So this is, here, my eyes are fake, but it is a 325. Then AD59, to mention but a few. But if you type this in Google and and say, hey, I see temperature sensor, then you. So that's a summary of things to do with radiation and temperature transducers. Remember, for temperature, the response is higher compared to the radiation. Because for radiation, if you had light and it had to knock off electrons in order to have your phototube or multiplier, it was not a must. No, it is not definitive. The light that comes, there are many other things. Maybe the orientation is in a certain way, but for temperature, the accuracy, the response time a bit improved. Because the temperature will change the resistance of the wire. This wire then would respond because of the change of the temperature. So it has to feel the temperature. If the temperature can't be felt, then it means it is not that much that would affect your instrument. Remember, in all we are doing is that we are looking at how we are planning, trying to apply the electronics we studied in order to make some instruments. This is the idea. It's not about, this course is not about defining the set state. But how can we understand the parameters that we use in order to form an instrument? Or if we already have an instrument like an oscilloscope, what could be those things that we are put into play? Imagine someone now knowing a cathode produces electrons and then finds out that you can accelerate these electrons and then they get dumped on the screen. And then you can use probes to make sure that these electrons can show you what is going on a given place. So some of the TVs, at least those of Nyash, there's one I bought and it had a circuit also put in the manual as part of the manual. The whole circuit of the TV with what component is here, what component is here. If you are using an oscilloscope, if you put here, what you will be able to show on the screen. So to repair it would be easy. That's why for most of the Bazungu, they have their toolbox at home. There is what they call, the videos you see, the DIY, they do it yourself. So the guy just rips off his TV and says, when you want to repair your TV, make sure you have this screwdriver, this screwdriver, this screwdriver, and this screwdriver. To get them, you can buy them in Chinatown. So you find Chinatown, you find that Chinatown now is sponsoring his videos for making these videos. And that's how people survive. I don't know how Africans intend to survive in the next 10 years without interconnecting, how do they call them? Not jigs, but if you don't look for a way of how to support each sector supporting each other, then you can't move any further. Because if now, under normal circumstances, winner class should be giving me suits and ties and shirts. So every time I'm teaching you, I say this is from winner class. And then you go buy from there. But you are mean. You wouldn't want to spend. Like Fred doesn't want to spend. So we start from there next week and start with capacitive transducers. Then we shall look at the inductive transducers. Then finally go into the communication system. And then understand the parts of the communication system in terms of how things are modulated and demodulated. And then talk about the instruments, and then the course will be done. And then next week, we are here on Wednesday to make sure that we enjoy the practicals. The robots are there, instructions are clear. So, since you have, through your lawyer, you have managed to, this is the lawyer, this is, I think, the complainer. And then so I'm defeated. So it will be 4:30 to 6:30. And then on Wednesdays, we meet the 2 to 4, and then we should be able to finish. I'm very sure. the speed I've gauged today. I think this comfortable pace will take us somewhere. And then I have scanned this section already of the lecture notes for the thermometers, lecture notes for capacity, and then communication system. Once I have put them together as a PDF, then I will be able to put them on the web so that you have no excuse. Yeah, I have no. In my work doing things, I don't believe in concealing my notes just because they are not my notes. They are in books. They are on Google. I give you everything. It is, and I've always given things, but still you don't want to consume. I mean you in terms of students, not you particularly. So see you next week. My weekend starts